Let's take a look at this example. We're supposed to again find the currents in the circuit using current divider rule. Okay, let me remind you that current divider rule looks like this. Ix is equal I total times R total over Rx. So in order to use this formula, I have to find total resistance first. So if R total is equal 1 divided by, open parenthesis, 1 over R1 plus 1 over R2 plus 1 over R3. Okay, this is equal, R total is equal 1 divided by, open parenthesis, 1 over R1 is equal 1.1 kilo ohm plus 1 divided by 6.2 kilo ohms plus 1 divided by 10 kilo ohms. This is equal. Okay, I'm going to use the calculator. So we have 1 divided by, open parenthesis, 1 divided by 1.1 exponent 3 plus 1 divided by 6.2 exponent 3 plus 1 divided by 10 exponent 3. Close parenthesis. This is equal 854.42 ohms. Again, please notice that the total resistance of the parallel circuit is always less than the lowest resistance in the circuit. So if the lowest resistance is 1.1 and we got 854.48 ohms, it means that our calculations are okay. Okay, this is of course 1.1 kilo. Now I'm going to use the current divider rule to find the currents. So I have, let me write this down over here. I have I1 is equal I total times R total over R1. Okay, so this is equal, I total is equal 35 milliamps times R total 854.42 ohms divided by R1, which is equal 1.1 kilo ohm. Okay, so this is equal 35 exponent 3 negative times 854.42 divided by 1.1 exponent 3 equals 27.18 milliamps. This is 27.18 milliamps. Next I'm going to find I2. I2 is equal I total R total over R2. Always write the formula first. So we have 35 milliamps times 854.42 ohms divided by R2, which is equal 6.2 kilo ohms. Okay, so this is equal. Use the calculator, so I have 35 exponent 3 negative times 854.42 divided by 6.2 exponent 3 equals 4.82 milliamps. 4.82 milliamps. 4.82 milliamps. Next I have to find I3. I3 is equal I total times R total over R3. This is equal 35 milliamps and I have 854.42 ohms divided by 10 kilo ohms. This is equal 35 exponent 3 negative times 854.42 divided by 10 exponent 3 equals 2.99 milliamps. This is actually 3 milliamps. So I'm going to write 3 milliamps. Okay, we found all 3 currents. But this is not the end of the problem, because we have to find also current which goes through this node. So this is current I23. Okay, so I23 is the sum of these 2 currents. So I have I23 is equal I2 plus I3. I2 is equal 4.82 milliamps plus I3, which is equal 3 milliamps. This is equal 7.82 milliamps. Okay, let's check if our calculations are okay. In order to prove it, we're supposed to use KCL, Kirchhoff current law, which says I total is equal I1 plus I2 plus I3. I1 we found is equal 27.18 milliamps. 27.18 milliamps plus I2, which is equal 4.82 milliamps. 4.82 milliamps plus I3, which is equal 3 milliamps, equals. Okay, let's use the calculator. We have 27.18 exponent 3 negative plus 4.82 exponent 3 negative plus 3 exponent 3 negative equals 35 milliamps. Okay, we got 35 milliamps, and at the beginning we had also 35 milliamps. So it means that all our answers are correct.